Hi, and welcome to another edition of Math with Mr. Douglas. Today, we are looking at comparing ratios and graphing ratios. Are you ready? Here we go. Today, we are looking at ratio tables, and we'll be using ratio tables, but we're going to be looking at ratios in terms of how to go and compare them. So a little bit of ratio comparison and graphing. And we're going to be using some of the things that we've already learned. So if you need to go back and watch some other videos, you are more than welcome to. And let's start off with remembering some things. So we need to go and recall a few things. The first thing is we need to remember what a graph looks like. So here is your graph. And just so you know, you have, this is your x-axis and this is your y-axis. And you know that you get things called ordered pairs. And ordered pairs just tell you how to move. And you always start right in the middle, and that's where the origin is. And let's just go and say you had a ordered pair, a coordinate, that was 2, 3. So remember, this is your x and this is your y. And it just says how you should move. So along the x-axis, you should move. So here's just some little numbers here. So there we go, 4 by 4. That means you start here, and he says, I'm going to move over on the x-axis 2, so I'm going to go over 1, 2. I'm going to go up on the y, 3, so 1, 2, 3. And that's where I would be, at 2, 3. So this would be 2, 3. That's where I am. So that is how we go and find points on our coordinate plane, on our graph, just as a reminder. So you need to remember that. And the other thing that we need to go and also remember, the other thing we're going to go and remember is ratio tables. So here's a quick little ratio table of, say animals in a house. So we have cats and dogs. And we'll say for every 1 cat, there are 2 dogs. So that means when there are 2 cats, there would be 4 dogs. And when there are 3 cats, there would be 6 dogs. And there are 4 cats, there would be, you got it, there are 8 dogs. And these are all creating equivalent ratios. So we have to remember that we get equivalent ratios this way. So we're saying 1 to 2 is the same as 2 to 4. Does that make sense? And there's different ways that you can go and figure that out. You could cross multiply just to check. What is 1 times 4? Well, that's 4. And what is 2 times 2? That's 4. So yay, these are equivalent ratios. And the cool thing about equivalent ratios, if we go back to our graph, so we're going to go back over here, is for equivalent ratios, you can go and graph those things, and you make a line. So if you're going to go and graph 1 over 2, you'd have to say that, well, the x-axis, I'll say those are my cats. And I'll say these are my dogs on the y. So if I had to go graph 1, 2, I would go 1, 2 right there, and 2, 4 would be up there. If I had a big graph, 3, 6 would be way up there. And you basically start getting a straight line, like this. So equivalent ratios basically will give you a nice straight line. And you can compare things. So let's get on to some new things now. So that was some good recall and remembering some different things. We're going to keep playing around with the idea of graphs, and there's some words that you're going to learn right now. And I'm going to draw 2 lines. I'm going to draw this line, and I'm going to draw this line. Imagine they're straight. And when you look at those 2 lines, I want to ask you which one is steeper. Which one is steeper? And hopefully you're going to say that the yellow one is. And it is steeper, and that means it has a kind of a bigger or a larger rate. So a larger, higher, bigger rate. Larger, bigger rate. And when you get into a little bit more math, that is going to be the slope. It's going to be a little bit bigger. So for instance, if we're going back to our, I don't think of cats and dogs, if you had a slope of 4, or a rate of 4 to 1, so you had, well, actually, let's just go and use the numbers that we had before, right? So I believe it was a slope of 2 dogs for every 1 cat. Is that what we said? Yeah? And if we took a look at, say, maybe what would happen when you had maybe 3 fish for every, I don't know, for every 1 mouse. That makes no sense. Which one would have a steeper graph? So you would go and take a look at those. And if you had to go and graph it, so 2 dogs for every cat, so another cat and 2 dogs, so it's like this. And remember, you kept going up and up and up like this. You drew a nice little line. Imagine those went through the dots there. Well, if you did the mouse one, for every 1 mouse, you had 3 fish, you'd be up here, and 2, you'd be way up here, and then way up here, and you do a line like this. And you just know that this would be the steeper, whoop, whoop, and that would mean it's a kind of a larger rate. Larger. So what you need to take away from this part is the idea of steepness inside a graph, because that is going to help you when we start comparing. That's where we're all going with this. So we're going to talk about comparing your ratios. And when we're comparing, we're kind of figuring out which one is steeper. That's what we're kind of really going to be looking at. And let's just go and use an example. So we're going to use a, let's go back to, so we're going to use a blimp. You guys know a blimp or a Zeppelin? Not Led Zeppelin if you're a music fan, but a Zeppelin. So a Zeppelin was a, here's my Zeppelin. This is how people used to travel around until they started to blow up. They were like a big balloon that would travel places. So they would you can look up, I think it's the, oh gosh, I forget the name of the famous Zeppelin that exploded. You can go and Google it. But it was pretty catastrophic, and it blew up, and people died and stuff because they were using basically gas inside here to travel on the balloon. But of course, we also have hot air balloons, and if you've ever traveled on a hot air balloon, they're pretty cool. So there's my hot air balloon, and people still go up in them, and for the most part, they're somewhat safe. I think there's still some accidents, of course, but so we had hot air balloons. So we had hot air balloons. And maybe I just wanted to take a look. I want to compare the ratios of which ones go up faster. So which rises faster? So this is a good question. Which one rises faster? And I'm going to give you some stats. So we're going to look at, so here we go. We're going to have time. So how much time does it take? And then height. And we'll do that for both. So we're comparing things. So time and height. What's the first one we should do? Let's go and do the, we'll just do the hot air balloons. So we'll call this I'll use pink, I guess. Pink. All right, so this is my hot air. Okay, so, and I said in 2 seconds, it went up 7 meters. And in 4 seconds, it went up 14. In 6 seconds, it went up 21. And what else? 8 seconds, it went up 28. All right, and also in 8 seconds, so when saying 8 seconds, it went up 28 meters. So these gives you all the different kind of ratios, and these are all equivalent ratios. Imagine they went up at the same rate. Okay, so just like that. And there we go. And you can say like, well, what is going to be happening? Which one is rising faster? Okay, so which one is going to be rising faster? So we're going to have to go and do something with those numbers. And let's get the Zeppelin numbers in here. So let's get the Zeppelins. And the Zeppelin will say in 3 seconds, it went up 9 meters. In 6 seconds, it went up 18 meters. In 9 seconds, it went up 27. And in 12 seconds, there we go, it went up 36 meters. So which one rose faster? So there's all of our kind of information that we're going to go and use a graph now to go and figure out. So let's go and take a look at that. Let's go and create a nice big graph. So here's my graph, and you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I'm going 15 lines. Pretty rough though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. There we go. So 15 by 15 grid. And let's start going and plotting some things. So our hot air balloon, we can start doing that. So if you remember what the numbers were there. So my hot air balloon, so 2, 7 was my very first one. So 2, so this is time, and this is height. So at 2, 7, so 1, 2, 3, 4, 5, 6, 7, it goes right about there. So there's my 2, 7. And then I had 4, 14. And you know what? I've already just noticed that if I'm going to go by ones up here, it's not going to turn out very well. It really isn't. So I'm going to go and change my scale. Did that just ruin everything for you? So just to make this clear, this is 1 in 15. And for my scale over here, I'm going to go up by 4s. I can just go and do that. That's pretty cool. So 4, 8, 12, and that means the very top here is going to be 60. And there we go. So this is going to be much easier now. So where's 2, 7 going to be? So 2, 7 would probably be right about there. 4, 14 is going to be about here. And what were the other numbers? I'm going to go back and forth here just to kind of see. So at 4, 14, I had 6, 21. So 3, 4, 5, 6. And then 21 would probably be about here. And I can start seeing a line. You can start seeing a line like this. I'm just going to draw a line right now. Okay, so that was my hot air. And then I'm going to go and do the same thing, but this time for my Zeppelin. So 3, 9, I think was the first one, so 3, 9. So it's already pretty close. So 3, 9's just about there, just kind of under there. And then 6, 18, so 6, 18 is going to be right about there. And then 9, 27 is going to be just about here. And I can start seeing a line. So I'm going to draw my line. And there we go. Saw some arrows. And that is my Zeppelin. Like that. So I said which one was going to be steeper? Well, which one looks steeper to you? You're going to say the hot air balloon. So the hot air balloon is going to be steeper. So that is going to be steeper. And what does that mean in real life? It has a bigger rate. So that means that it would rise faster. So looking at the steepness of two different things. So while we had the information that we just learned about the kind of the steepness, so looking at the steepness, we can also do this mathematically by looking at the different rates or the ratios. So let's just stick around with what we just had. So remember, whoa, that was craziness. So the hot air balloon, so remember the hot air, this is the last thing we're going to kind of touch upon today. So the hot air, for every 2 seconds, it went up 7 meters, right? So the hot air did that. But for the Zeppelin, every 3 seconds, it went up 9 meters. Now, if I want to go and I want to compare things, so I want to compare, I could go and graph it and just take a look at, which one was steeper. But we can also change things into the, you guessed it, the unit rate. So we look at the unit rate. And if we want to look at the unit rate, let's just go and convert this into unit rates. So do I want to look at something per 1 meter or something per 1 second? And we're thinking about this. I probably want to go and look at things for every 1 second. So I want to go and figure out how much was 1 second. How high did it go? Just like that. And over here, I'd want to do the same thing. I want to know and say, how much does it go in 1 second? Like that. Now, some of these are hopefully you can kind of do these in your head. So how did 3 go down to 1? Well, you divided by 3. So I'm going to go in here and just going to go and divide by 3. And of course, that would just equal 3. Over here, maybe a little more harder, maybe a little more challenging. So I divided by 2 here. And over here, I have to divide 7 and basically in half. So that's going to be a little bit harder. It's going to get 3.5. And that's going to go and tell you how fast it rises. So every 1 meter, it rises every 1 second, it rises 3.5 meters. And this one, for every 1 second, it rises 3. So if you had to say which one rose faster, you would say, obviously, the hot air balloon rises faster. So this one is faster. Yay. And that means when you graphed it, the line was steeper, just like that. So a couple of different ways to be comparing things, because we're going to be asking you to go and compare things. Your teacher, your math teacher, will have you going through random worksheets, probably asking you to compare all sorts of different things. Usually cars and distance, or how much food somebody eats for how much money. But you can compare things, and again, you want to be thinking about, so when comparing, think about unit rate. The unit rate is an easy way to compare, and you could also probably go and you could graph it, but I'll be very honest with you. Most kids just go and figure out the unit rate and they say which one is bigger or faster or things like that. And there you go. How to compare ratios with a little bit of graphing and a little bit of unit rate.